All right. Now we are recording to the class. Hopefully this time everything is resolved. All right.
Yeah.
Okay.
Okay.
Yeah, we're ready to go. Finally.
Yeah. Oh, I think we should somehow also record our behind the scenes so that someone someday we may want to share that with the audience as well.
I agree. I agree. So we had lots of difficulties today, and we were trying multiple different settings to finally can record our faces when Moein is sharing his screen. We are still not 100% sure if the problem has resolved, but at least that's the best that we could do so far. So let's give it a try and see how the output video will be for today. All right, so just a quick update before we start. So Moin and I discussed a little bit before starting the recording, and we wanted to share the outline of the topics that we have in mind in advance so that the two of us can be a little bit more synchronized among each other and maybe keep the topics that are more similar to each other discussed at the same time so that we jump less between completely different topics. And in light of that, the topics that I'm going to discuss today kind of fall into five broad categories. I'm going to quickly talk about LLMs, like the previous meeting, the new DeepSeek models, the OpenAI O3, a little bit about Deep Researcher. And, I'm not going to deep dive into any of those because, to be honest with you, I didn't have a chance to play with them that much, but just maybe kind of first impressions. And then a little bit about how LLMs work, a couple of new topics, some educational, some paper-like on that. A few different topics regarding AI in medicine, and a couple of different publications came out that caught my eyes. I have an interesting topic regarding brain decoding, basically how to convert what you have in your mind to um, tangible outputs like textual outputs or image outputs. And then finally, a couple of cute ideas that are small, um, totally irrelevant to each other, but kind of still interesting to me that I wanted to bring up if we have time at the end. So this is what I have on my plate. What about you?
Um, Great lineup of topics. I'm really excited for that. For me is the same kind of. I'm not going to go very much in depth in these topics. Uh, they were two very busy weeks for me, and for me, the one that I will dive a bit deeper is about study on head city foundation models and two prior works on that matter. Then there's a research paper on a huge clinical trial in AI that I'm really excited about to share the results. And also deep research from OpenAI is on my list. Another blog post about the new field of AI engineering is on my list. And there are a few other things I'm not sure if I'm going to share, if I have the time to share, but mostly the others are random blog posts that caught my eye during these 2 weeks that I think would be interesting for you and if anyone's seeing this video. And yeah, I think we can get it started.
That's great. All right. So maybe to put the big topics of the weeks aside very early in our conversation, we can talk a little bit about the new LLMs that came out and the things that caught our eyes. I have one thing to share with you. There is this website, so let me go ahead and share my screen.
Yeah. Yeah.
So let me bring that. Okay. So there is this website that I recently learned about. Uh, am I sharing a screen of my browser now or in the entire screen?
This is the entire screen. I see your desktop.
So let me just go with the um, here you go with the browser only, right?
Yes.
Okay, perfect. Yeah, there is this website name, artificial analysis.ai. I wasn't familiar with this one. I'm not sure if you already had heard about it. But this is a nice one. This is basically, a website that compares all the new LLMs that come out with each other. So if I can get rid of this nav bar that is open.
That is really cool. I mean,
Yeah,
I
there you
will definitely bookmark this one. Yeah.
So this is a very nice one. So I just learned about it a few days ago. So it basically compares all the new models that are out there, very generally regarding their quality, their speed, and their price. But if you come down, if you scroll down, You will also see some more specific kind of benchmarks as well. For example, regarding the MMLU benchmark, Math 500, coding on human eval, and all these different types of benchmarks. It has some new diagrams here, some plots here, for example, artificial analysis quality index versus price. So they have their own quality index versus price of the model. And you can see what models are actually cheaper while giving you the highest quality. Also regarding quality versus speed and many, many different types of comparisons. I don't know at all about all the features of this website. They have different arenas, they have different leaderboards, different models that they can compare to each other. And basically you as a user can select to compare whatever two models that you like. So I found it very cool and I found it a very nice, basically a single resource to compare all these different models that emerge every day. And to just maybe, and I found it as kind of a nice starting point to talk about DeepSeek, O3 Mini, and then the Gemini 2 family of models that came out recently, and somehow compare them with each other. So I'm going to just introduce these three plots very quickly here, just some insights from them. So the first plot on the left-hand side is regarding the quality of these models. And as you can see, so O1, which is the most expensive model OpenAI has, apparently has the highest quality here, but very, very close to that, we have both O3 Mini and DeepSeek R1, which are both new models that came out. So DeepSeek R1 came out the last time that we were talking about it 2 weeks ago, and then shortly after OpenAI released O3 Mini that is very, very close to DeepSeek R1, and in many different comparisons might even beat DeepSeek R1. So I'm going to talk about that a little bit later, even though I didn't find any kind of official comparison, but I have a blog post that I might be able to share with you about that. Regardless, these basically have very similar qualities. And then very close to them is Gemini 2 Pro that is still in the experimental format, so nobody can access it within the API as far as I understand, or maybe very limited access. Then we have O1 Mini and Gemini 2 Flash. So Gemini 2 Flash is actually the model that caught my eyes the most. Look at the quality. It's not that far from O3 Mini or DeepSeek R1. It's much better than GPT-4o, Llama 3.3, and even Cloud 3.5. Where is Cloud? Here we go. And so Cloud 3.5 Sonnet, GPT-4o, and these models that we basically take it as granted that they are the best, most mature models. And you see that Gemini 2.0 Flash, that is not even the pro version of Gemini, is actually better in quality from these models. And now if you come to speed and price, you really see which of these models stand the most. So DeepSeek R1, even though it offers a very nice quality, it caught everyone's attention. Unfortunately, the native API of DeepSeek is very slow. And if you remember, their website was actually down for 8 days. Basically, their API was not working. So as far as I understand, both due to the speed issues and also due to concerns regarding the safety of the data, a lot of people who are working with DeepSeek R1 are not working with the deployed versions of DeepSeek R1 that are offered by platforms like OpenRouter or Together.ai. So basically, not too many people are working with DeepSeek R1 native API. Yet still, if you work with that, that's not going to be the fastest option to play with DeepSeek R1. Whereas O3 Mini has the fastest API possible, fastest speed inference, probably because both the model is very optimized and OpenAI has lots of infrastructure to offer the fastest models. And you see here that Cloud 3.5 Sonnet, unfortunately, is not that fast. But if you go to price, again, you see that here we have, GPT-4. So O1 is obviously the most expensive one. I don't think that anybody here is going to use O1 anymore, given all the new models that came out. Cloud 3.5 Sonnet remains one of the most expensive models, even though they are not one of the most modern models. But very close to those, you have DeepSeek R1, which basically is kind of relatively very cheap models compared to the ones that, 3.5 Sonnet or GPT-4o. These models are reasoning models. So basically they can give you the more reliable type of output, yet their, output per token is not, their price per token is not going to be that high. Maybe if you just sum the final number of tokens that the model needs to generate for you to give you a reliable answer, and then the price is going to be more comparable. Yes, still DeepSeek R1 is actually quite cheap. And then O3 Mini in terms of output is going to be a little bit cheaper. And then we have GPT-4o mini and Gemini 2 Flash, which is actually the cheapest of all the models here, but look at the Gemini 2.0 Flash speed and also look at the Gemini 2.0 Flash quality. So I guess that's the model that really caught my eyes. Definitely O3 Mini, DeepSeek R1, very great models from many different standpoints. But if you compare if you take into account all these three different factors, then Gemini Flash, I believe is a very nice companion. I'm going to basically replace GPT-4o Mini with Gemini 2 Flash from now on. And again, on this chart, just take a look at these three different models that we talked about. O3 Mini is here. Again, the x-axis is showing the price, dollar per million tokens of output, I believe, and then the y-axis is the quality index. So O3 mini falls here. Obviously, as the closer you are to this top left-hand corner, the better. Let me zoom in a little bit. I saw that you are trying to uh, zoom. Yeah, look a little bit closer. So we have O3
Thanks
here.
a lot.
Yeah, and then we have where is DeepSeek R1? DeepSeek R1 is here, so a little bit more costly compared to O3 Mini. So we have DeepSeek R1 over here, and then Gemini 2 Flash, where are we? Here. So very, very cheap, not that far in terms of quality. So that's the first thing that I wanted to share. So I'm very quickly going to talk about a few other things as well. So first thing is that, as I mentioned to you, I had a comparison between OpenAI, O3 Mini, and DeepSeek R1.
I wanted to add a few things here.
Yeah, please go
Do
ahead.
you
All right.
prefer to interrupt you here or
Yeah,
just at the end of that?
feel free to interrupt me wherever you like.
Because you also talked about the Gemini model. I also saw the announcement.
Okay.
I think it was this week or 2 weeks ago. I'm not sure
Yeah,
which
not
week
not
it
that
was.
far. Yeah,
But yeah, the very kind of prominent thing about this announcement was the low price of it, which makes it actually the cheapest API
yeah,
among all these providers, which is a very important thing. I mean, startups and companies will definitely compromise that much of quality for such a huge drop in price. I mean, probably no one detects that 90 what 85 to 90, but that huge price difference will be a killer for OpenAI.
definitely.
I mean, it kills the product, not
Def-
that meaning of killer. But Gemini, I think, is the Gemini team are doing a great job in just seeing how to make a product out of their research. I mean, yes, they are behind in terms of probably quality from OpenAI, but I think this lower price makes its adoption much easier and is will be the more reasonable option for the startups to go to. And when lots of startups go for APIs of one model, that will become sort of the go-to option, the default kind of LLM, and it would be difficult to take the market out of its hands. So I think Google will prevail with this strategy, and I really like how they're approaching this. They're quiet, they're not making big announcements like OpenAI or DeepSeek, but they're doing it in the right way. I'm not sure how this is going to end, but I think it's really promising the way that Google is doing this. And I also had a question. Do you know what this quality index kind of
Uh, not
encapsulate? What are the perspectives they are comparing these models to in this quality index?
To be honest, I'm not quite sure. I didn't deep dive into this. And I should have. I should have, but I didn't deep dive, so I'm not quite sure what they're
Mhm.
measuring
No,
here.
it's okay. I
I
mean,
should be kind of an average, maybe, of most of these kind of known
probably, yeah.
benchmarks that we know. I'm not quite sure if they are averaging these or if they have their own kind of custom quality benchmark. But when you look at these custom benchmarks here downstairs, the one that we already knew about, like human eval, MMLU. So the quality index that they have come up with is not that different from the.
Yeah, yeah.
So it seems that how
It
this.
would probably be a combination of all of these benchmarks and probably the arena scores, the ILO scores that these models get when compared along each other based on human preference. It could be a mix of all, but I also need to check it out. But this is a great website. Thanks for sharing.
Yeah, sure. And regarding the point you mentioned about Google, I believe Google is prevailing now, or at least very, very rapidly closing the gap between itself and OpenAI, because now Google is showing the power of the infrastructure that it has had and it has collected for years. Yeah, OpenAI emerged as a very big name, as a startup, raised lots of money, yet Google has been the dominant player in the world for decades. And
Yeah,
now they are actually they are putting their strongest card on the table, right? They are just basically playing with the card of infrastructure, and this is something that OpenAI, I believe, is still far behind from Google, regardless of how much money they have raised and regardless of how much investments people have done or big corporates have done in OpenAI. Still, Google has resources that OpenAI itself cannot compete with unless it goes and maybe tries to leverage more from Microsoft resources or those other big names that can be a rival for Google. Otherwise, Google can, keep the prices very low because they have lots of compute, because they have lots of infrastructure, and they can easily scale things that OpenAI cannot
definitely.
do at least that easily. So that's my take on this. But
Yeah, definitely. And I think they're much more experienced in the game of scaling things and making products for the masses.
yeah,
OpenAI is new to this game. I mean, they are very good researchers, very probably they know how to work with each other very efficiently and release new features, new models very frequently, but they are not probably that good in the product side. I mean, they're the idea to introduce a $200 plan for the Pro feature, I don't think that's a great product idea or it's going to help OpenAI that much. But Google, by being just able to spend much more money and being much more experienced in making good products, I think this is the reason they are making their game very quietly but very strongly in this LLM area. Yeah.
I agree. I totally agree. And I believe the other key player in the game that has not yet shown um, any any eye-catching kind of product, or in my opinion, has not yet played their card, is Apple. Apple also has lots of compute. Apple has lots of end user devices that people are using. And Apple, if they really want to leverage from the kind of edges they have, they can do amazing things. But I think the policies that they have so far endorsed on AI is not good. I mean, they have not been good policies. The Apple Intelligence
Yeah.
obviously a big failure. I mean, it's not even 1% of what they claim that to be. And I believe Apple has the potential to do much more, but they didn't go that route. Yet Google actually used all its resources in a very wise way. They closed the gap rapidly, and now they are becoming the go-to model for most of their stuff. GPT, this Gemini Flash is actually amazing, right? If I want to do something very something that needs lots of reasoning, something that is a difficult and challenging task to tackle, yes, maybe O3 Mini or DeepSeek. But if you really want a model for your day-to-day jobs, for your experiments when you're coding. And I was previously using GPT-4o Mini. Now with this pricing and with these capabilities, Gemini 2 Flash is definitely going to replace that.
Yeah,
So
definitely.
yeah, it's an interesting area.
Definitely. So, yeah, you were sharing
Yeah.
the
So
other, yeah, links.
I
You
just
can,
wanted to quickly talk about this blog post. As I mentioned, when OpenAI O3 Mini came out, I had an eye on seeing, how DeepSeek performs compared to OpenAI O3 Mini. And I watched a couple of videos on YouTube that try to compare the two, but I didn't find any of those, and also not this blog post to be very comprehensive and very systematic. Yes, this blog post kind of sums up some of the important things to have in mind. My my take from this blog post was that, and let me zoom in a little bit. So obviously there are different cost, comparisons here. This blog post, I like that because it kind of is more suitable for people who are using O3 Mini and DeepSeek R1 for development. So, if you're a developer and if you are using these models to just help you with your coding projects, then you have three obvious choices ahead of you. I mean, I guess most of us were playing with Cloud 3.5 Sonnet. If you are on Cursor, this is the kind of a default model that Cursor offers to you. And then we have O3 Mini, and then we have DeepSeek R1, right? So it seems that, first of all, in terms of performance, we know that these two are very close to each other, and they both beat Cloud 3.5 Sonnet. When we think about the costs, DeepSeek R1 is actually still the cheapest one, right? If you look at the input and output price, and if you are working with the DeepSeek R1 API, the native API, not the one that Together AI offers or OpenRouter offers or other providers offer. The reason for this comparison is that they wanted to compare it with the native API of DeepSeek. So O3 Mini is a little bit more expensive, yet it is less expensive than GPT-4o. It is less expensive than Cloud 3.5 Sonnet. And if you just try to force O3 Mini not to generate the longest output for you, the longest reasoning output for you, you are still going to have much better performance than Cloud 3.5 Sonnet and probably be able to pay less. And the context window for these, so O3 Mini and Cloud 3.5 have the longest club context window, 200K. DeepSeek is unfortunately on 128K, but it's still 128K is still too much. I guess most of the GitHub repos could easily be fit into the memory of 128K tokens. The other thing that caught my eyes was that, when working with Cursor, unfortunately, DeepSeek R1 is not very optimized to be able to be used with, those smart IDEs like Cursors. O3 Mini and Cloud 3.5 Sonnet both are great from that standpoint. But if you really want to use Cursor or something like Cursor's Windsor, for example, for doing your codings, then DeepSeek R1 is going to be a very poor choice. Basically, it's not that much, comparable with Cursor and basically these very high level coding tasks. And whereas O3 Mini and then afterwards, Cloud 3.5 Sonnet on the second place are very much optimized with that. So this is something to have in mind if you're going to work with that. And again, I didn't deep dive into any of the specific experiments that the blog post is talking about. But this is my understanding of these experiments that, if you are working on a coding project, if you want to have a real coding repository in which, you want different files to be placed, you want the IDE, a smart IDE to be able to help you with, coding and putting codes in different organizations you have in mind, then O3 Mini is the best option you have at the moment. And if you are willing to pay more, or maybe stick to the standard option, then Cloud 3.5 Sonnet remains your standard go-to option. DeepSeek, unfortunately, is not the best for using these smart IDEs, but if you want to just try their own API or maybe, just work with it as you do with, the web-based API of Cloud and OpenAI, so basically just ask it to create an entire project for you in one single chat, then yes, DeepSeek R1 is going to shine there as well, but not if you're going to incorporate it into Cursor. That was the second resource I wanted to introduce. Now, I'm
Great.
not sure, Moin, if you have played with any of those for code development or if you have any take on this.
No, these days I'm not doing much coding myself, but the analysis here and what you mentioned was very close to what I was reading on my Twitter or X's feed these days, from based on people's experiences with different LLMs as the backbone of Cursor, or the LLM behind the CoPilot they were using when they were coding. And most people were saying that, yeah, Claude 3.5 Sonnet is probably doing a very good job these days. And I think I saw less about the good side of O3 Mini for coding. Maybe because of the speed is not that great, but the good thing about Claude, based on what I saw on my feed, was that it is very fast and it is very good at understanding code and refactoring it. And yeah, people were still encouraging others to use Claude as the backbone LLM in their Cursor application or any other plugin that they are using for code assistance, anything. So yeah, I think I'm not sure what Claude has done for training on code, what data set they've used, what methods they've used, but they're probably doing a very good job there.
Yeah. Yeah, Claude actually continues to shine on coding benchmarks since the first day it came out. Uh, they were great and they have been great on coding tasks for a very long period of time. I guess O3 is the closest alternative that we have to Cloud 3.5 at the moment, and it is very nice, compatible with Cursor and other those smart IDEs. But Cloud 3.5, even though not that much of a new model, it still holds its superior place compared to many others in coding. I want to also share two quick things, and then I will stop sharing. That would be the end of my blog for LLMs. First thing is that so last time we talked with each other, I spoke regarding DeepSeek and structured outputs. Later on, I figured about this new page in DeepSeek kind of documentations. I believe this. I mean, they offer some tips and tricks for making the model produce structured outputs as much as possible. It's still not as clean implementation as what OpenAI has, or what Cursor has. But they tell you that if you're coding with DeepSeek API, you could just pass a response format to JSON object. But this is not enough. Then you also need to mention the word JSON in your system or user prompt, which is not that much of a clean implementation, I believe. And then also set the max tokens in a way that the model can generate the JSON you're expecting. This is a reasonable expectation, I would say. But again, they say that even if you do all of these, there are time to time your model might actually return an empty JSON output for you. So this is not something that you have in mind. So I think that DeepSeek is not the best model to produce output structured. And as far as I know, neither of the providers, US-based providers who are also offering DeepSeek, have been able to tackle this problem. Yet O3 Mini came out with very nice compatibility for JSON outputs from the very first day it came out, and also Cloud has had it for a long time. So I think this is a big bottleneck for many of the applications that are going to be built on top of DeepSeek. So this is something for people to take care of. That as far as it's an open source model, I really don't think that this bottleneck is going to be there for too long. Probably people will finally address that. But so far, I just wanted to bring this point up because last 2 weeks ago when we last talked, I mentioned that this one doesn't have any support for output structured output, but probably they're offering something at least.
Yeah, and I think based on the research that has been published on LLMs so far, one of the best use cases of fine-tuning is to teach models these specialized output structures. And I think a good fine-tuning regime is needed to be applied to the current DeepSeek R1 or other similar models to make it compatible with those pipelines that need these sort of structured outputs. And these ad hoc or post hoc methods like putting it in the prompt or just give it to the model in context somewhere is not going to solve the problem always. Maybe it works somewhere, maybe it doesn't, but with fine tuning, it will get much more reliable outputting these sorts of structured outputs.
I agree. I totally agree. My last point, which was a model that came out, and I really expected that to attract more attention. It did, but I believe it's very soon fall in the shadow of OpenAI O3 Mini, is this DeepSeek Janus model. So basically, this is a very nice model. DeepSeek also released another model a little while after the DeepSeek R1 release, which they called a Janus Pro model. Apparently, they already have had this Janus family of models. I wasn't familiar with those. The one that I heard of was the Janus Pro one, which is their newest model. And this is a very interesting model because it's both a multimodal LLM that can basically understand your text and image inputs at the same time. And it's also an image generative model. So basically, it can also generate images for you. And I mean, the model is amazing for two reasons. First, it does both of these tasks at the same time for you. And the way that they have done it, as they mention here, is that they basically decouple the encoders for generative tasks and for understanding tasks. So their models have two different encoders that work at the same time. One works for the purpose of generation, and one works for the purpose of understanding. And then they have, one single unified decoder that can take care of both at the same time. So if we go to paper, they have a nice figure there that they show this very nicely. But again, I guess this is a very nice trick. that many other models could also use. So as you see here, they have an autoregressive transformer. The autoregressive transformer is the main LLM, but they also have the encoder that can take care of, encoding the language instructs. And the language instructs is going to be similar for both generative and understanding tasks. But they have one specific encoder for image understanding, another specific encoder for image understanding for the purpose of generation. And then finally, all of these use similar decoders for text and image to generate whatever output the model is intending to generate. So I guess that was a nice trick that they did. Another interesting aspect of this model is its size. So basically, DeepSeek Janus model comes out, I believe, with very light variance. I'm trying to figure out, yeah. So you see they have two different models here. One of them has only 1 billion parameter, the other has 7 billion parameters. And this is very nice because the 7 billion parameters could easily run on a Mac Air, I believe, and you even don't need to just go through any API-based resources for this model. So you can basically, I'm not sure if Ollama offers these models at the moment, but I believe very soon we will have these models on our own computes, and then you can basically use them even on your own mobile phones as well, because the 1 billion parameter model is actually very small. And then it's very
Mm,
nice. Yeah, go ahead, Moein.
no, no. Continue. I will
No,
add my comment
one more
here.
sentence, one more sentence. So it's actually this lava model that I saw here, the lava is actually the 7 billion version of this model that kind of came earlier than Janus, that this model actually beats that very nicely. And you see that if as you go forward, we have other even larger models like this token fellow X large that is much larger in terms of parameters, but still in performance is not as good as uh, Janus Pro version of models. And these are all the images that this model has generated. And we can even go to the paper. There is a nice figure somewhere that they show an example of the photos that they could generate with this. This is a nice one. You see, I mean, they have a nice comparison with the Stable Diffusion X Large and Llama-Gen, and these are state-of-the-art image generation models. And you see that the performance of this model is not that bad at all. Yes, the Stable Diffusion X Large model, this one really catches my eyes. Janus one is not that bad either. Uh, Definitely most of these figures are cherry-picked, no doubt in it. Stable Diffusion also cherry-picks its kind of figures, but I think we have a very nice light model to at least run locally and do some experiments with before moving to those more expensive cloud-based APIs of a Stable Diffusion.
Yeah, and I saw this announcement, and I think uh it lost the attention because of the O3 announcement afterwards. I have 2 points about this. One is that I played with the 7 billion version on a demo on, I think, Hugging Faces Spaces, if I'm not mistaken.
Okay.
And the first thing I wanted to try was the quality of image generation, because it still feels magical that you can generate images with text. And the thing I found out and really got disappointed with was that the quality was not as
Oh,
they
really?
are advertising.
Really?
And I mean, it's not just low quality, it generates gibberish images sometimes. And I wasn't, and I hadn't a similar experience with DALL-E or the other, in the Stable Diffusion XL. It was kind of weird. And I was kind of doubting that are they serving their original model, or is kind of like a downgraded, I don't know, quantized model that is not very well quantized, that is kind of like it seemed to me like a broken model. I'm not sure how much of the lost attention is due to this, that people went there and tried it and it wasn't that great, and how much of it is because of the O3 announcement. But that was something to take into consideration. Maybe it's improved now, but at the time it was really disappointing.
That's very interesting to know, and I'm kind of surprised about that. Maybe it's because of the bottlenecks of Grad.io and how Hugging Face permits models
Could
there.
be.
Maybe because I know that they don't offer very high compute to models that you want to host on Grad.io, and Hugging Face.
Yeah, I think that sort of outputs look like the model is not ready yet. I mean,
Yeah,
um, I really doubt that they release a model like that intentionally. I believe that their evaluations on the benchmarks that they are comparing to Stable Diffusion and DALL-E, um, probably they are okay. I don't think that they are generating or synthesizing good numbers there, but the model didn't seem all right there. But anyway, the other point was that the cool thing about these current and new architectures that do both the understanding and the generation in somewhat a solid and monolithic kind of architecture. It's not many models working together. It's basically one model, different modules, which still is a one model. And this is something that I think will probably replace the older architectures. And the cool thing about this paper, if I'm not mistaken, is that they are not using diffusion in any of this
Yeah,
process for image generation, and they are still training the generation in a autoregressive manner.
yeah,
And they're using ideas from the VQVAE GAN paper from probably 3 years ago, and which introduced tokenizing images, which is a really crazy idea that you basically map float numbers from a continuous space that is not anything like text, which has different tokens already taken place for you to just map them to some embedding. They actually map the continuous space of images, which are float numbers, to some discrete tokens, and they make a cookbook. I think that is the name they refer to for these tokens made out of many millions or billions of images. And they set a number. I mean, like for example, a vocabulary of 100,000 tokens, and these are image tokens. So each token probably gets out decoded to one patch, but this patch could be, I don't know, maybe sometimes a few brightened dark pixels, and some other tokens get decoded to some, I don't know, circular patterns. And basically, this is a discrete codebook that could be decoded to the continuous space of images, again, to float numbers. And they're again training this whole training regime in an autoregressive manner, which is a very cool thing that it actually works. And yeah, this is a big difference in comparison to diffusion models. That is a whole other story that I think maybe we will cover in some other news someday if something happens in that area.
yeah.
But the cool thing is that the whole diffusion scheme that was once very, I mean, it was all on the news, and every research paper on image generation was using diffusion models, is kind of now another alternative to autoregressive. And I think we will be training models in an autoregressive manner for any purpose sometime soon.
I agree. So first of all, that VQVAE paper that I believe first was introduced in VQ GAN paper a couple of years ago, that is such a great and such an inspiring idea. I really like that. I still don't think that if I fully understand that, every time that I read that paper, I find some new insights. But that's a very great idea, for tokenizing images in the latent space. And I believe that was lots of these latent diffusion models also use that idea, but later on, people realized that they could also use the same idea for generating images in a autoregressive manner. So that definitely is true. Now, I know that I already told you that I'm going to stop sharing. I'm going to reveal one of those cute ideas that I wanted to mention at the end because that's very close to the concept that you talked about. And that's regarding a paper that I recently learned about. And I just looked at it, skimmed it a little bit. It's named PixelWorld. Did you hear about it?
No.
That's the paper. So what this paper is suggesting is basically exactly the opposite of what you said, right? Not to say that what you said is wrong, but I'm saying is that they want to do exactly the opposite. They are saying that instead of just moving from the pixel space to token space, let's move everything from the token space to the pixel space, right? And they're saying that, you know, at the end of the day, I mean, their rationale kind of makes sense. They're saying that, we as humans, when we look at a page full of text and images and all the different things at the same time, we do not, I mean, in our mind, we are not going to split the graph from the text and say, "Hey, okay, the graph now goes to a VLM, the text goes to an LLM, the plot goes to another one." We do not process the text, or we do not process PDFs the way that the current state-of-the-art pipelines do, as they break every page of PDF or web page into multiple different components and process them separately. Everything is just an image, and our mind is tuned to process that image completely in a unified manner. So they're saying that why not to get rid of tokens and change everything to pixels? And their idea is kind of crazy, but they show that, it is kind of doable, right? And even they do that, they try to do that with the current models that we have. So they take those visual language models that we have, and they try to basically process everything on a page as pixels. So for example, if you have a text like this, I mean, this is the final version of the model, the way that they are finally offering to process the text. So they do some sort of processing in order to get rid of the white spaces on the page, because this is going to be a very sparse data if you don't do that. So they kind of convert everything to patches of data. As you see these blue squares on the screen, this is kind of patch making strategy. And then they try to understand what is written on the page by converting everything to pixels rather than tokens. And I am not familiar with the details of what they have done, but longest story short, again, this is what they are doing. So they say that, in a plain framework, if we have a page like this, we separate the table, we separate the graphs, we separate the text, the tables and the graph and everything goes to an OCR module, which basically tries to understand what is written in the page, in that figure, using a vision language model, and the text directly goes to the language model, and then we have an output. In their proposed framework, everything goes to a VIT without any processing. So everything is processed in a unified manner. Now, they talk about some results, and for the sake of results, I guess it might be better to just look at here rather than going through their tables. What they show is that, first of all, PEEP, which is the name of their framework, outperforms baseline with token-based input in multimodal datasets. So they say that, if we look at the multimodal datasets, PEEP is going to work better than those transformers that, try to separate the text from the vision. Second, if we use the current models that we have, for example, coding capabilities, all of these models, I mean, neither of these models can do coding in a pixel-wise manner. And it's kind of makes sense because neither of those models have been trained like that. So if you want to, for example, to use Cloud 3.5 Sonnet, which is a multimodal model, to help you with coding, but just looking at your code rather than, typing your code into this prompt, is going to have a much, much less performance, because then, their capabilities for processing pixels are much more limited. And they say that even if you are going to basically use if you are going to have the same setup, but instead of asking the model to do a task that is very reasoning intensive like coding, just ask them to do non-reasoning tasks. Again, the performance of the models drop, but here, those bigger models like 3.5 version of Cloud Sonnet, and then, GPT-4o, those models are going to be hit a little bit less than others. So those models might maintain their performance. Long story short, they are saying that, the current family of models are not capable of processing everything as pixels. If we force them to do so, their performance is going to be dropped, and the drop is going to be more intensive in areas that needs reasoning. But if you are comparing the model on completely multimodal data sets, basically multimodal tasks, then their proposed framework is going to work better compared to the ones that we have. Again, crazy idea, kind of a cute idea, very, very primitive research at the moment. But I kind of like that idea as well, that maybe instead of just tokenizing everything, we can pixelize everything and see what happens. So I wanted to put it here after what you just said, because those are the two opposites of one extreme. And I'm not sure which of them are going to survive in the landscape of AI in the next few years.
Yeah, this was a really crazy idea, and it reminded me of a paper that I shared with you a few sessions back before we were recording these meetings, and I can. Are you done with the sharing, or is there anything else on your? Yeah, I want. This wasn't on my list um, for this week, but this really reminded me of a way that a paper back probably a few months back approached a similar problem, but in a similar pattern and strategy. Let me see if I can find it. The name was ColPali, and this is now a well-known kind of approach to doing visual RAG in the community of RAG and everything.
I remember
Let
that.
me share my screen. Yeah, just for the purpose of putting it aside, uh, what you already showed. The idea here was that they had a very good figure one. I think they have yeah, edited that maybe. Yeah, the idea is that instead of doing RAG on the tokens and first OCR in PDFs and extracting text from them, just doing the whole RAG pipeline on the kind of like the JPEG screenshot of PDF pages. And they did that in an efficient manner that I'm not going to dive deep into. But the idea is that they embed the whole page taken as you can consider that page as an image, which doesn't do OCR, doesn't extract the tables. It is just an static image. But the encoder sees all that image and embeds that in a few vectors that I think is on the order of a few hundred actually. But they are small in size and the whole pipeline is very efficient. And when a new query is given by the user, which is basically a question in text, the embedding of that text is compared to all these image embeddings, but those image embeddings are trained to entail the content of that page as well. And they show that this whole pipeline works by using saliency maps when the user asks a question about a graph and a specific question on which part of the graph actually shows this number, the model is actually seeing or looking into those pixels. So the model is learning the meaning of the text in there, the meaning of elements in the graphs. So I think maybe this is basically a much easier way to do document understanding instead of just doing first extracting all the text using OCR and then extracting all the tables and trying to figure out how to reconstruct that table in a meaningful manner. And yeah, it was a really a crazy idea, and I need to go in deep into that paper because these kind of pipelines are really interesting to me.
Yeah, this was interesting as well. I remember now the rack paper you mentioned, and yeah, that was also a crazy idea, to replace the entire rack with just visual components of understanding, and basically with just a series of OCR operations on the paper. Very nice one. And again, we should wait and see which direction finally the researchers go to. But we have two different streams of research, one that wants to tokenize everything, and the other that wants to pixelize everything. And I guess both diffusion models and transformers are still very, very hot topics for research. So both will probably grow. All right, so Moin, that was the end of my topics for LLMs. So do you have any points on the LLMs, new models, deep research? I didn't talk about deep research. I believe you have more to share. So if you have anything to share with
Um,
that, let's dive, deep dive.
yeah, I mean, not very much in depth for deep research. Basically, I saw the announcement on the demo, and I think probably most people have seen that. So maybe we can skip it because I think I have some other topics that is
Okay.
basically a gear shift from what we were talking about. It's
Awesome.
basically about
Yeah.
medical imaging and how and the foundation models there. But if you want to keep the team for the LLMs for now, if you have anything else on the LLMs, you can share now.
Yeah, I have only one paper. So first of all, regarding deep research, I also don't have anything to share. I mean, As you said, we just saw the demo. No, none of us has that $200 per month of the plan that OpenAI is currently offering deep research to. So my understanding is just based on the reviews I watched on YouTube. There was a paper that I liked. Let me just quickly share, and also one Jupyter notebook that I wanted to share. So, and I should go here, I believe, again. Okay. So the paper, the Jupyter notebook, just to close the topic of deep research, is this one. Very soon after deep research came out, somebody just released this package,
Nice.
GitHub Open Deep Researcher. This is a nice one. This is just a notebook. And if you open the notebook, you can open it on Colab and work with that itself. So it's basically based on Open Router API and a couple of other APIs that I believe just help you with the scraping and searching. And the idea is very simple. So if you go back to the GitHub repository, it talks about how it works. So basically just does some Google searches for you, fetch and extract web page content, interacts with the LLM for generating search queries, evaluating page relevance, and extracting context, and everything just works in a while loop. So as far as your LLM, your brain behind the entire operation is not satisfied with your results, it continues the searching and searching and digging and deeping and going into the websites. So I just wanted to say that very, very soon after deep research was released, somebody put together an open version of that. And the entire code base could basically fit on a single Jupyter notebook on Google Colab. So if someone is interested, this is a nice Colab to go and take a look at. Very cute project. That was one. And the only other kind of LLM related that I wanted to, so I have a couple of things regarding LLMs. So if you are going to shift gears, I can very quickly introduce those. Neither of those are going to take time. First thing is this paper that came out after the stream that DeepSeek initiated. And not sure if you saw this one, but this is a great one. This is a very nice comparison between supervised fine-tuning and reinforcement learning. And I believe the entire message of the paper could be summarized in the title. So they
Mhm.
basically just compare supervised fine-tuning with reinforcement learning, and they realized that, as they nicely mentioned in their abstract, based on a couple of different experiments, that RL, especially when trained with an outcome-based reward, generalizes in both rule-based textual and visual environments. Supervised fine-tuning, in contrast, tends to memorize the training data and struggle to generalize out of distribution in either scenario. So it's a very nice point. We all have heard about, and there was soon after the release of ChatGPT, this huge hype about just fine-tuning a large language model for your own purpose, whether it is a Llama that is hosted locally or it is an OpenAI that now has an API and offers fine-tuning. Fine-tuning, if you are a radiologist, if you're fine-tuning your model on your own reports, this doesn't mean that your model has learned a new knowledge. This basically means that your model has memorize something. So if you want to let it memorize something, the best thing to memorize is actually your output desirable format. That's why supervised fine-tuning is perfect for just teaching a new format to the model. And as Moein mentioned, basically just teaching, for example, how to generate structured outputs. If you really want to teach them new knowledge, if you want to teach them a capability to then generalize to an out of distribution domain, then reinforcement learning is the plan to go. But they also show that despite reinforcement learning superior generalization, we show that SFT is still helpful for effective RL training. SFT stabilizes the most output format, enabling subsequent RL to achieve its performance gains. So it's very similar to the result that the DeepSeek R1 paper was talking about, that we want some safety in the first place as the founding baseline of the model. And then on top of that, we need to do apply reinforcement learning to enhance the capabilities of the model. That's a cute paper. It has some details, a lot of details we can go through. I'm not going to talk about it because I just wanted to be as quick as possible on the topic of LLM. Moin, do you have anything to share on this?
No, that's fine. Yeah, I mean, one name caught my eye here, Sergey Levin. I mean, he's a god in
Really?
RL, and it's
Okay.
really interesting that I saw his name here.
Okay.
And probably, I mean, this gives kind of a credibility to the work. I mean, and so that I need to also go to this paper as well. If you check out the Google Scholar, you see many of the interesting ideas and research papers in RL are from his work.
Wow, wow. Yeah, definitely a great researcher from Berkeley. Wow, I'm mostly working on policy optimization, I believe, as I can see, very much into reinforcement learning and everything. Awesome paper, awesome author, definitely, and group of researchers, and also very nice experiments. So these icons they used here for affiliating themselves is actually quite related to the experiment that they did. Then one of their main experiments, which was with card games. So I would say that this is a very nice paper to go through. It's this really I mean, the final message of the paper is already clear, but still learning about their experiments is somewhat interesting. So that was one thing I wanted to share. The other quick things to share is basically this, I believe, a YouTube video from Andrej Karpathy that came out 2 or 3 days ago, I believe. This is just a very nice, very nice video on how LLMs work, how LLMs like ChatGPT work, and I believe there is no need to introduce Karpathy to anybody. He's a great researcher, great instructor. And whenever he releases a new video on something, everybody just wants to watch it as soon as possible because probably it would be the best education that you can receive regarding how LLMs work in basically the most recent LLMs. And he just released that 2 days ago, so I believe there are lots of exciting things there to learn from him. I have not yet myself watched that, but this is a guaranteed content. So even without watching, I needed to
Yeah.
read.
And also, I'm seeing that he has currently 600-ish subscribers, which is a crazy number for an engineer. I think probably he's the most subscribed engineer in the world.
It certainly is. It certainly is. Yeah, and then also another course from deeplearning.ai. This is my last content to introduce regarding LLMs. This course also came out 2 days ago. So deeplearning.ai is doing great. Every week they come up with a mini course, and that mini course is great. So I watched that mini course they had on computer use completely, and I learned a lot from it. And now another one that is coming out, how transformer LLMs work. Very nice one. And so the guy who is actually instructing in this course, both of them are co-authors of this book, Hands-on on Large Language Models, that also raised a lot of attention when it came out a few weeks ago. So it's a nice book. Again, 1 hour 35 minutes. If you are not even tuned for the 3 hours of Karapathy's video, at least deep dive into this one and learn a little bit about LLMs. And that's
Yeah, I know Jay Alamar from his blog on, I think, Visualized Transformer it was. One of the first blog posts that visually explained how Transformer works. And probably a big percentage of my understanding of how Transformers work, the illustrated Transformer, yeah, came from this blog post. And I got to know his name from this one. And yeah, I mean, the only bad thing about this uh, deep learning AI courses is that it gives you this feeling that you are not enough and you don't have enough time to go through everything. And they're always coming up with new courses, very interesting and timely courses. I mean, whenever a new topic emerges and this is an important topic that you need to know about, they have a course already somehow. I don't know when they have the time to go through it and polish it and everything, but it's really interesting that they are this quick in making these high quality courses. But I have a big list of these courses to go through and I never catch up with it.
Well, kudos to Andrew Ng. I guess 99% of credit goes to him because of being this much influential in AI education. You and I both learned AI by watching his videos, I believe. So I've never met him. I have lots of respect for him, and he's great, and he's now still doing great things. Very thought-provoking videos or post every time that he makes a post on social media, and also this great work with deep learning.ai. Hey,
Yeah.
so anybody's interested, there are very cool resources for you out there to go and learn a little bit more about transformers and LLMs. All right, Moein. So let's shift gears from LLMs towards whatever you have for us.
Yeah. Okay. So, this week, one thing that really caught my eye, I mean, a few days back actually, was this paper. Let me share my screen here. Um, this is in a totally different world that from what we were talking about. This will be considered, I think, narrow AI compared to what these LLMs and VLMs are about. It's still a foundational model in terms of the huge data sets that they pre-train the model on. But this is no LLM or VLM. This is for only this is a pre-trained model in a self-supervised manner in only vision that could be fine-tuned to do narrow tasks like detecting the hemorrhage, detecting the midline shift, or something like that. And this is a paper out of the NYU, and Dr. Razavian was the lead on it. And this is a 3D foundational AI model for generalizable disease detection in head CT scans. And the cool thing about this paper is that it is highly technical with lots of great details about how they did everything. And they documented literally every decision they have made. And I think this is totally reproducible, at least if you have 800 GPUs for a few days. But this is a great paper for learning how to train these models, how to go through the pre-training steps, how to go through the fine-tuning steps, and lots of hyperparameters are mentioned, lots of nuances in decision makings of how to choose a certain, I don't know, technique is mentioned here, and nothing is overlooked. And I really liked this about this paper because more and more we are seeing companies or research institutes publishing papers without sharing much about how they did this whole thing. And they're also sharing the whole code base, which is a mix of PyTorch, Moein, and other tools for making the whole thing work. And let me see if any specific, yeah, this figure is actually whatever they did. They have a huge pre-training step on, I think, let me see the exact number, on 600,000 CT scans, which is a huge number because those CT scans have lots of slices, of course, and this will be lots of 2D images if you want to
Yeah.
think about them in a 2D space. And they use Dino and MAE, masked autoencoders, for the pre-training step. And they find that each of these methods does well on certain downstream tasks, which is, I think, expected because the features they will learn probably will be useful to some tasks and not to others. And they go through the downstream fine-tuning data sets, they introduce them, and then in the figures in the supplementary, they compare two baseline sort of models. That's the other papers that I'm going to introduce next are on those papers that they are referring to. Let me see if anything other, I mean, this is a very detailed paper. I'm not going to go through them. And this is something that if anyone is interested, should go through it themselves. Let me see.
This is a great paper. I have two questions. First of all, did they only focus on brain hemorrhage, or did they train their model on different CT scans with different pathologies?
No. The pre-training stuff is on a huge data set, a private data set at NYU, I think,
Okay, yeah, they're
or
from
NYU
NYU.
hospitals that entail, I mean, any probably pathology that CT scans can show in the brain.
Okay,
And the final fine-tuning data sets, they also are multi-class or sometimes multi-label data sets. They're not only for brain hemorrhage or the other pathologies that was mentioned in the abstract. There are many of them, but they are advertising it as a baseline or basically a foundation model that could be fine-tuned to do many tasks on head CTs. It probably won't work well with MRI. It probably won't work well with another region of the body, like abdominal CTs, but it is probably a very good start for training models on head CT scans to detect something or to do some narrow task on head CTs.
definitely. Very nice one. And second
Yeah,
question from
yeah.
NYU, I believe part of the reason that they're focused on self-supervised learning, and I know, is that NYU
Yes.
is where Jan LeCun is, and this stuff comes from. I was kind of surprised not to see his name among the others.
Yeah, but his soul is present here with the
Yeah.
with Dino, and I think also MAE. I'm not sure if he was on the authors of MAE, but yeah, these are the focuses of Meta and the teams working under supervision of Jan LeCun. And it's no surprise that NYU is also focusing on this techniques to train models. Okay, do you have any other comments or feedbacks on this one?
Just to make sure that I understood. So basically, this model is a self-supervised model. What it gives you, the baseline model, is a set of features, and then your final classifiers that you can fine-tune for downstream tasks are going to receive these features and are going to be fine-tuned later, right? So basically, you are going to fine-tune the head, the classifier head that is going to attach to these features.
I think they also open source the model weights. I'm not sure if they're doing so. So you can basically train or fine tune the whole thing, both the backbone and the head. It's not like those APIs that only give you the embeddings
Yeah.
that you will use in some downstream pipeline. But I'm not sure that they are sharing the weights at this moment or they have
No, no, no. I
postponed
mean,
it to some time in the future.
their code base aside, I was just curious about their own paper. So the way that they set up their pipeline was that they trained one very large self-supervised based embedding model, and
Yes,
then
yes.
classifiers that receive that embedding model were fine-tuned
Yeah,
afterwards,
basically.
depending on the task.
Yeah,
Gotcha.
basically a huge backbone which is pre-trained in a self-supervised manner, and then for fine-tuning on downstream narrow tasks, they will add classifier heads and yeah, whatever else necessary that uses that backbone as the first component that the image goes through, and then the features come back, and then it goes to the classifier. And I think they fine-tune the whole thing, probably with different learning rates, but the whole thing is fine-tuned. It's not just a classifier.
Yeah, that
Uh,
makes
but the fine-tuning is totally supervised, and yeah, it's like whatever else we expect in the classical deep learning. So this was it, and the other papers that I'm going to introduce are the um, baseline models that this paper compares to. Let's first see the post by Dr. Azavian that introduces this. We built a 3D VIT foundation model on this number of head CTs at NYU Medical Center on 4 datasets. And they also use, yeah, now I'm seeing here that they also use the EHR data as kind of to find out the labels sort of from them to be able to use them in pre-training. I'm not sure about the exact way that these are introduced to the model. This is something that I need to go deep through. Probably sometime I want to implement this paper, but they are also using this EHR data. So it's probably kind of like multimodality
yeah.
model. And yeah, they say that open source methods and models, and they're comparing it to Med Gemini models and also a model called Merlin
Yeah,
from
it's from
recently.
Google, I believe, right?
Merlin, I think, is from Stanford. I'm not sure. I will share the paper soon, and we can see the affiliations. But I think this is not a fair comparison because both those models are VLMs and they're trained to do multiple things, and they're not just head cities. They can interpret many other modalities. They can understand text, and it is expected that a model that is only trained or pre-trained on head cities will outperform those things on head city benchmarks, but it doesn't mean that they are doing a totally great. This is, of course, a precious work, and it's not. I'm not going to undervalue what they've done, but this way of comparing results, I think, is not fair, and it's kind of like cheating.
Yeah.
Because if you pre-train MedGemini, the whole model, the whole transformer with this dataset, that will probably do the same thing. So this discussion aside, I'm going to shortly introduce this paper Merlin. Yeah, Stanford and Louis Blankmeer with Akshay are here, which both have the Cognita startup, and
Yep.
the other people are from Wisconsin Madison and Yeah, I think most of them are from Stanford.
Awesome.
And this is basically for abdominal CT. Yeah, the other weird thing is that this model is optimized for abdominal CT, and they compare it to this one, which
Yes.
is I don't know.
How do they do that?
It is weird, and I don't know what they thought that they are comparing this one. And yeah, this is another VLM that is trained on a huge data set of you can see the numbers here. We trained Merlin using a high quality clinical data set of paired CT scans, 6 million images from 15,000 CTs, EHR diagnosis codes, and radiology reports. So this is a much broader number of modalities introduced
Fibers.
here. And yeah, I'm now I it came to my mind what is that both Akshay and Pranav are working on abdominal cities, and I'm not sure why really.
Well, because
And
abdominal CT scans actually have lots of differential diagnosis, right? And this is they are widely used. A lot of people who come with multiple different clinical presentations, you want to order an abdominal CT scan for them to understand what is going on. And the number of pathologies that are in an abdominal CT scan is huge. So it's a very it looks like a very challenging benchmark for people working on LLMs and medicine or radiology to basically be able to become on par with an abdominal or body radiologist and how they read an abdominal CT scan. Abdominal CT scan is widely used, very, very frequent, and can come up with actually very, very different types of pathologies as output. So much more diverse pathologies than a head CT, I would say.
yeah, and yeah, many more organs are involved, and it is probably a bit more challenging than a HIT CT, for example, like going through the intestines to see whether there is a blockage or something is probably much more time taking than just seeing if there is a hemorrhage in this in the brain. And yeah, in that sense, yeah, it makes sense. It is much more common and much more time taking to go through. So startups based for automating this process will probably be popular when they are ready to be used. And yeah, this one was the other paper that I had missed before. I hadn't seen this when it was published, but when they in this work they compared to Merlin. I went through the paper. I just basically read the abstract and put it for some time else to go through in depth. And the other baseline model they are comparing to is Med Gemini. And let me see if I can find the papers. There are two papers that introduce the Med Gemini series, and I'm going to just introduce probably the titles, not all of it. And yeah, the first one is this one, Capabilities of Gemini Models in Medicine. It was soon introduced after the Gemini pipeline, the Gemini family of models was introduced by Google, and they basically pre-trained or fine-tuned basically the Gemini model on medical purposes, like those that Palm model was first trained on, the MedPalm model. And they like always, reported lots of good numbers on the medical benchmarks like the USMLE exams, and these are the things that make the headlines for the news. And after that, they recently, I mean, more recently, introduced this one, Advancing Multimodal Medical Capabilities of Gemini, that they introduced more modalities and fine-tuned it even further for medical tasks. And this model also it works with 2D images, it works with 3D images, and it's not anatomy restricted to any part of the body. It works on chest X-rays, it works on head CTs. So it is a much, I mean, more capable model. And it doesn't make sense to compare to it and say, okay, our model is better than Gemini, because this is what they are proposing in their paper, that our model is outperforming Gemini, our model is outperforming blah blah. And all I'm saying is not that it's not a fair comparison.
There's
And yeah, these are also other good papers to go through. that I had missed, and I'm really upset that I had missed lots of good papers here. But the kind of disappointing thing about these papers is that you cannot reproduce any of this. I mean,
Yes,
you do not have the computation power. You can go through it and just enjoy. Okay, it's really great that you can do these things, but yeah.
it's the
But the fact that these
models.
yeah yeah and the fact that these efforts are underway is promising, but it's sad that independent researchers out of these big companies probably cannot contribute much to these sort of research projects. So yeah, um, I think this was what I wanted to share here. And yeah, something else here to share again from Google. And this was introduced a while back.
Hmm.
And the difference is that MedGemini, the previous one, the MedGemini models are available only via API on Google, on GCP services actually. So you can't access the model weights. You upload your data there, and you probably get some embeddings back. And this is only available through APIs. And you cannot tweak the model on anything. But Google also has open sourced a few models for chest X-ray, pathology, and dermatology, and these are open source models and open weights models. So the weights are shared there on Hugging Face, which is I think a very valuable thing to do that Google has done. And I just hope that we see more and more of these sort of publicly available models from these big companies, because these models could only be trained with these huge computational powers that these big companies have. And yeah, it makes sense that they don't want to share them with public, because they can make probably lots of money out of it, and they should. But this one was in contrast to the other ones, in the sense that the weights are available. So if researchers want to go if researchers don't have lots of computational power to train their own models, they can just start off the weights from these chest X-ray foundational models for obviously X-ray images, and the other two for their relative images and data, to save on lots of um, computation, and only focus on building classifier heads actually on top of these embeddings to do their tasks. And yeah, this was on this topic of medical image analysis using foundational models, and how the whole landscape is changing. I
Yeah.
mean, we are still seeing works on narrow AI, but the work like this one from NYU, which is basically a huge VIT pre-trained in a self-supervised manner, is the kind of the narrowest thing that you can see these days. And those models that we were training 4 or 5 years ago, a single resident on a single task, are probably going to be outdated, or are outdated soon, unfortunately, and yeah, replaced by these huge models. But yeah, this is a new trend. We need to get used to it, and just I think these papers that share lots of things about how they train the models, how they design the whole research, are very valuable in this regard.
Certainly, yeah, very interesting paper. Thank you for introducing that, Moein. And I agree with your points regarding the unfair nature of comparing this model to the other huge models that we knew were already published on CT data, and they could basically look at different parts of the CT scan and come up with different diagnoses rather than being only focused on head CT. So I mean, I believe even there was no need for such a comparison, even if they had just showed that their model is good on their own test set.
Yeah.
That would be much better because their data only comes from NYU, as far as I understand. And if that's true, then your model is actually going to be a very good self-supervised model for your own use cases within NYU. And that's a good trend, from time to time for at least large medical institutes like NYU. It's worth to try to come up with your own model because you already own the data. You have these huge data sets. So definitely a model that is trained on your own data is going to perform better down the road compared to whatever public model that you get and try to fine tune for your purposes. So I would say that what they have done is very valuable. Probably it could even look more valuable if they didn't need to compare that to Gemini models and all other those models. Now that everybody is thinking of, people who read this might think of, why did they actually compare this model that they developed with those models? This is not a fair comparison. So I would say that they actually did something unnecessary. Uh,
Yeah,
and yeah, and I think the other point you mentioned regarding the unfortunate nature of seeing many models released from Google and other these big corporate names without having any details of their papers, or at least adequate details of their papers, is the truth of nowadays status of research in AI. It's only once in a blue moon that a paper like DeepSeek comes out and they have released every single detail of what they have done. And you see that when they do so, the entire community kind of moves forward because now all of these big names know that, oh, everybody now is aware of their secret sauce. So they need to share something new. They need to accelerate their research. They need to release more public and open source models. So it's going to be a game changer. And I would say that uh, what has really kept the entire competition of AI very nicely on the top of the news is these kind of open source releases that every once in a while happens from either academy side or companies like DeepSeek, that they release everything and now everybody else has to follow them, otherwise they're out of the game. That's
yeah, definitely.
Regardless, very interesting one. So now that you shifted gears towards medicine, let me also go ahead and share a few things. I'm going to share three different resources very quickly, and then I'm going to deep dive into those brain decoding articles that I mentioned to you earlier, okay? And
Yeah, and before I think I mean you can go through the short ideas that you mentioned, but I think before going to the brain decoding, because that would be another shift, I still have another paper on a big trial in
oh, okay.
medicine and AI that I will share afterwards. Yeah.
But then why don't you go ahead and share that? Because mine is kind of short announcements. All the three papers that I have is a short announcement. So if your topic is going to be a more in-depth review of that paper, let's do that first.
Yeah, I will share, but it's not going to be that
That's
in
okay.
depth because this week I didn't have much time to go in
No
depth with
worries.
everything. But let me
So far, very
see.
interesting papers introduced as always.
Yeah, okay. This paper I think is going to be a very important one in
Mm.
the kind of the history of AI and how it's going to be integrated into medicine. And I'm really thankful to these people making these clinical trials because I think this is the only way that you can prove that AI will help in anything in real work. Because anything in research is retrospective and it is far from the real context of how medicine is practiced. But when you integrate it and in a blinded clinical trial, no one can say that this effect could be ignored. And this is something that proves that AI is going to be integrated into clinical practice. And I think they are introducing a very good way to approach this problem of how to integrate AI into whole day-to-day clinical routines. Okay, this is a paper on a big clinical trial with 105,000 participants. Started between 2021 and 2022. And this is very important because this is the technology of AI at those days. And
Yeah.
we know that the AI landscape has changed drastically from that time. And still, the models are doing a perfect job, as you can see from the results there. They basically divide these, let's say, 100,000 participants into two groups: the intervention group and the control group, as we expect. And in the intervention group, there is an AI application, AI software that is going to be used for first seeing the images, and the images are mammographies for a screening of pathologies and malignancies in those images. So in the intervention group, first the model sees the images and it predicts a few classes like low risk, high risk, and medium risk. And then if necessary, there is an human physician that goes through those flagged categories. But in the control group, no intervention, of course, is done, and it is done in the classical, traditional manner that um, only human physicians see these screenings. And if they see anything abnormal, they recall the patient to come back to the clinic and do the further tests and anything else. So to just first go through the results, and they are very promising. I need to say that, okay, here you can see I had some okay, not all my highlights are here, but I need to find them here. Cancer detection rates were 6.4 per 1,000 patients, screened participants in the intervention group, and 5 per 1,000, which makes
Hmm.
a ratio of 1.29. So the AI has detected 29% more cancers compared to the control group. And I think this
Mhm.
is a huge outcome, and no one can ignore that. I mean, in a with I mean, this is not going to be a random discovery with this p-value and this number of patients included. And also that the other important thing is that the recall and false positive rates were not significantly higher in the intervention group. So the AI is not doing this higher detection by just recalling more patients, just saying more false alarms. The false positive rate is similar to how humans perform, but the detection rate is 29% more. So, I mean, this is crazy to think about that 29% more people could be diagnosed with cancer, and this is the ground truth here is the pathology results. So they definitely had the cancer, and they would be missed if AI was not used in the pipeline. And also that the positive predictive value, the PPV of the recall, and here recall means that when the physicians and the hospital calls the patient to come back to the hospital for further investigations, the PPV of these recalls was significantly higher in the intervention group, and this one 19% more than the control group. So if the AI says the patient has the disease, it's 19% more probable than the baseline that the patient has that disease. So I think these are very important things, and this is not the end. And the cool thing is here is that, as I told you, the AI helps the physicians in the intervention group to just ignore a few or more than a few, lots of images because it detects them as no risk, and those could be ignored, and or maybe go through only a single study instead of a double study by physicians. So it's designed in a way to save times, and they measure this time saving, and is that in the intervention group, resulting in 44% reduction in the screen reading workload. So all these benefits, 29% more detection, higher PPV, same false positive rates, and 40% reduction in workload. And I think this is crazy. And I think this is one of the best approaches to integrate AI into clinical practice in a way that still there is supervision on the results, but there could be huge gains by reducing the workload just by ignoring the cases that the AI is certain about the prediction. Those that are a bit uncertain or need further supervision for any other reason still can go through the human physicians to assess, but that will lead to 40% reduction. And let's say 50% because it's more than 40. And this means that the hospitals can hire half the number of staff, or in another way, the patient can have time for double the number of patients that they can serve. And this is another very interesting outcome from this paper. And yeah, this was it. And there are lots of cool methodology described, how they designed the whole thing, what the AI sees that the physicians miss, and lots of other cool tables and comparisons that I think makes it a great paper and research project that helps us understand how AI will impact the future of medicine.
Thank you, Moein. This is very interesting. I have a question regarding the setup of the intervention group. So it was AI plus radiologists, right?
Yes.
And then first AI screened the images, ruled out basically those images that AI certainly said that have no cancer were put aside. Those that AI said had cancers or were in doubt of were reviewed by radiologists. Did I understand it right?
Yes, and also that those images that are introduced for a second kind of look by physicians are in two categories. Those with low and medium risk go through a single read only once by physicians, but those that are flagged as high risk, there are two rounds of reading it to make sure that the patient has the cancer to recall that for further investigations.
I see. This is interesting. And also a more nuanced question. Did the radiologists in the intervention group know about the diagnosis that the AI put on the image before they read the study themselves?
I'm not sure. I think so because first AI sees them, and then yeah, as I remember the from the paper, both the prediction and the certainty level of the model is reported to the human physicians.
Okay.
Yeah.
Yeah, this is an interesting research question. I'm not sure if they did any ablation study to test the effect of this, in advanced knowledge of the radiologists on their performance. But I remember that there was another paper that came about 2 years ago, very interestingly, on breast mammography screening again. And that was also a clinical trial, but retrospective clinical trial. So they didn't do a prospective study like this one. That was a retrospective trial with many different compromises that the researchers needed to do because of the retrospective nature of that. But one thing that they studied was that there was a significant difference between a setup in which the radiologist is aware of the prediction that the AI model has made and another setup that the radiologist and AI read the study blindly and radiologist later on understands about the prediction of the AI model regarding the study. They were saying that, this in advanced knowledge of radiology is kind of like making their minds biased towards
Mhm.
whether or not believe what AI has said or not. If you're pessimistic about AI and the AI says that this imaging has cancer in it, then your mind is already biased to say no. And if you are very optimistic about AI, then your mind is already quite biased to say yes. So they were saying that, there are pros and cons towards having a radiologist know about the AI prediction in advance or not knowing about that. So that might be an interesting question for researchers like this that are going to come up in future. But regardless, very interesting study. I'm very happy that finally people are doing randomized clinical trials using AI, even though unfortunately the traditional setup of RCTs require years of a study and then models that are going to be models that are going to be tested in those trials are unfortunately going to be outdated models by the time that the trial is done. Yet still, I guess this is a very cool study. This is a very nice methodology, and probably we could come up with methodologies that still let the models to, let that more recent models to be tested. And when we get there, then it will open door to deploying many new models in the world of medicine that unfortunately nowadays cannot be
Mhm.
done because of all this mistrust in AI.
Yeah, and also a more specific answer to the earlier question, image marks and regional scores were initially masked to the readers who were
Uh-huh.
instructed to turn these on and at the end of the case reading. So they first came up with their own interpretation and then they could see, okay, let's see what the AI thinks.
I set
But
up.
they had to do this in the intervention group. So no case is unseen by the AI, some
I
sort
understand.
of
Yeah.
thing. Yeah,
But it's
yeah.
still a nice one. At least the radiologist's mind is not going to be biased then while
Mhm.
making.
And also, I remember another work in this kind of investigating which methods to combine AI and human physicians is the best. And they found that the addition of AI to the pipelines is not helpful in their task because the people always kind of tended to stay in a biased way to their initial thoughts, and they wouldn't change their minds even if the AI is saying to do so. So yeah, I think this probably depends on the personality of the physicians, probably how experienced they are or what experiences they had with these models and how educated probably they are in how to use them. So yeah, this was a cool paper, and I hope we can see more of these sorts of evidence because this thing is kind of no one can disagree with the findings here or question it in a way that some physicians do, like, okay, will AI really replace us, or will AI really be useful in the clinical practice? Yes, it will be, and it will be in with this evidence, and I hope we can just see more of this. And this has been definitely a very difficult project to run and to control. And yeah, and this is one of the reasons why there are not many works like this one.
Yeah, certainly, but it paved the way for many others, certainly. If you look at this paper now, you can have a lot of ideas for doing something similar in other fields and just wait for the results. So I'm very happy to learn about this, and thanks for introducing that, Moein. Very nice one.
Yeah, definitely. So yeah, feel free to go through the other topics you mentioned.
So let's me share my screen again. I probably need to just open another one.
Pouria, can you pause the recording for a few seconds? I can go back if it is feasible. If it's not,
All right, so we had a small break and both of us are now back. And while we were away, I was just looking at the number of papers that I have left. I'm trying to ignore a couple of those cute ideas as I mentioned to you that I'm going to bring up at the end because we are already, I believe, past, I'm not sure how many minutes, I guess past 1.5 hours at least. So I'm going to talk about a few small introductions in medicine, and then I'm going to finish with brain decoding, and basically that's going to be my last topic, okay? All right, so let me share my screen. Uh, Here we go. So, I'm going to introduce three different things very quickly. The first thing is this paper, MedXpertQA, benchmarking expert level medical reasoning and understanding. The reason that I brought this up was that as we are seeing more and more reasoning LLMs to come out, it seems that we need to have better benchmarks in medicine as well. Most of the benchmarks that we so far knew in medicine have been focused on, multiple choice questions and kind of USMLE-like questions that these models could easily handle. And even if they did not already have the knowledge of those questions in their memory, because the questions are available everywhere. The other part is that, MCQ questions are not that much high. You do not need that much of reasoning to be able to answer USMLE-like questions. But what the authors of this paper have done is that they have put together a multimodal data set with lots of nuances and basically with many different image types, ECGs, pathology slices, radiology scans, and from 11 different systems, 17 specialties, multiple tasks, in knowledge reasoning, and then basically the way that they put together, I mean, this is one example of their data set, right? They have this nice clinical presentation, and then they have an imaging data next to that, and then they have, I mean, this one has again a multiple choice as the final answer. But the point is that the model for being able to answer this needs to go through a lot of data and needs to know a lot of different nuances that the previous data sets did not offer. So this is something that I believe would be a harder benchmark for LLMs that are going to be applied to medical questions, like those three papers that you introduced earlier, Moein. I guess that might become one of the data sets that we will see more and more models to be tested on. And to just see how hard this data set is for the model, you can take a look at these data sets here. So we have these. So MMLU is actually not a medical one, but basically a standard general knowledge and reasoning data set for models. then we have MedQA, and then we have MedMCQA dev. So these are the two already known datasets in the world of medical LLMs. And now they have proposed this MedXpert, and this MedXpert, as you can see, most of these, at least not necessarily a state of the art, but the standard models nowadays have much less performance on. So, for example, Qwen 2.5, 72 billion parameters, GPT-4 O1 model, an O1 model, it is already performing less than 50%. And then DeepSeek R1, which is one of the highest, one of the most hyped models at the moment. So I'm happy that a new dataset came out, and I'm pretty much optimistic that we will need more and more datasets like this for the sake of testing the LLMs or VLMs in the world of medicine. So I just wanted to introduce this to anyone who is interested in testing LLMs on
Yeah.
medical tasks. Go ahead.
Yeah, and this is a really important aspect that I think was missing the benchmarks for. We had all these new reasoning models, but we didn't have a reliable way to compare them in medicine in terms of reasoning. And I also randomly saw this paper that if you don't mind, you can share it yourself. I don't, in order not to change the screen shares. And this one also compares the reasoning of AI models compared to physicians. Apart from the kind of the news thing, the superhuman word there that I'm not very a fan of. This is also compares the ability of models and humans in terms of reasoning. And I think and they use O1 preview for these comparisons. And yeah, I mean, it was kind of related to this one that you introduced. It's not a benchmark in that sense, but it is a good way in a more descriptive manner. Not a, it's not a qualitative, it's not a quantitative. It's more a qualitative comparison, but it's still a good way to compare humans to LLMs in terms of this reasoning. And yeah, I just wanted to share this. I thought it was a bit related to the one that you mentioned.
Definitely, this is interesting, and they have a nice figure here: performance of differential diagnosis generators and LLMs on NEJM clinical pathology case conferences 2012 to 2014. My only question, immediate question, is that did this model
Yes, in the
act
training, yes, in the training data.
interesting? But still, yeah, I mean, it's good that people are thinking about that we need more robust data sets, more challenging data sets, more reasoning type kind of data sets for these new LLMs. That's itself a very good thing. And still, both of these could be very nice food of thought for people who want to do research in LLM data in the intersection of LLM world and medicine.
Yeah,
Quickly jumping to the next one is this one. I guess that's no, sorry, that's the paper that you said. Let me copy this again. So I saw a new paper coming out that was published on BMJ. So the name is Future AI International Consensus Guideline for Trustworthy and Deployable AI in Healthcare. So it's kind of like, a standard for publishing an AI. I'm trying to find out the PDF of this somewhere. Hopefully they have it here. Oh, there we go. That was on the other side. All right, so this is a paper. Lots of researchers, and I believe it comes from, I'm not sure where they are. I guess they are from multiple different institutions, so probably not only from one institution. But lots of researchers collaborated with each other, and the coordinators of the study basically sought their opinions in multiple rounds of a Delphi-like kind of study. And then what they finally came up with was a set of 30 different guidelines that they all categorize that under this abbreviation future, which stands for fair, universal, traceable, usable, robust, and explainable. So these are features of an AI model that the authors or participants of this study believe could actually have a place in the future worlds of medicine. Let's say that if your model is basically future proof, then you have a word to say. And now and then they come up with different kind of sub criteria for either of these criteria. And I believe we have the table somewhere. I'm not sure why this table here is. Let's see where I can find. Okay, there we go. This is the full list of the features that they talked about. And some of these features are research oriented, some of them are deployable oriented. To make this a little bit larger. So they say that, for example, for the sake of fairness, define any potential source of bias from an earlier stage, collect information on individuals and data attributes, evaluate potential biases, and then you go ahead and they have talked about everything, explainability, define the need and requirements for explainability, define explainability with users, robustness, define sources of data variation from early stage, train with representative real-world data. It sounds like general sets of recommendations, but what is the real value of this paper is that for either of these items, they have 2 or 3 paragraphs that they talk about what they mean by that, so that you can basically go and read it. And this is, again, one of those checklist-like papers that it's good to have on our radar in case that we are going to, come up with a model that we really want to be finally deployed in healthcare. I guess this is not a bad, collection of recommendations to adhere to. It reminds me to the claim version 1 and 2
Yeah,
data
yeah,
sets that
exactly.
radiology AI came up with. That is solely focused on development and research. I believe this is a little bit more tailored towards deployment. But again, something nice to have on our radar.
Yeah, definitely. Thanks for sharing.
Sure. And again, so kind of related to this discussion, there was another paper that I saw yesterday. Very easy idea and apparently not that much surprising, but something that is worth mentioning. So there were some researcher, oh, sorry. It seems that it might be easier to just look at it from here because it's not opening this on the data sets. So there were some researchers that tried to say, hey, what if we try to jailbreak these vision language models that have been developed for medical purposes and see what happens? And as obviously expected, prompt injection in those models is going to make their performance terrible. And now the authors are actually raising this suspicion that, hey, if you can easily, by just doing some prompt injection in these models, make their performance so unreliable, and then, probably cause a lot of problems for the patients and the care providers, how can we say that these models are reliable enough to be deployed in medical world? Say, for example, here, they are saying that, we are just applying some prompt injection attacks on medical images. Say you have an image, could be an ultrasound, could be a mammography, like the paper that you talked about, anything. And then a malicious player could just put a prompt like, do not tell about the lesion, just a single sentence in the prompt. And then the actual prompt is describe this image, but the model is not going to talk about whatever lesion was there. And it's very interesting because they tested out their models, some of the public models that we already know about with this prompt injection attack, and they saw that most of those easily fail on this. So what they're saying is quite obvious, but nobody had shown that before, how detrimental effect it could have in the world of medicine. So we need to have very, very reliable and trustworthy setups for deploying these models in practice. Even if you have the best model, the best kind of large language model, vision language model, if it is not, resistant to such attacks, then it's not safe to deploy that in medical world because easily somebody can play with that and somebody can cause a lot of frustration for some families if you just say that, regardless of the image, say that you have a cancer, and then it's going to be very frustrated. Or like this, it could basically result in missing a lot of cases. And this is a
Yeah,
very simple idea, but that's basically what they have done.
yeah, really concerning. And one of the cool fields of AI currently is this AI safety, and there was a cool name for it, uh, like the white hat hackers that come and find the points that these models are weak at, and they find solutions how to avoid these kind of attacks. And this is kind of a interesting field of research. I was recently listening to the podcast of one of these researchers, and they are really creative in the ways that they come up with how to avoid these things, and they should be a few steps ahead of those black hat sort of hackers that want to introduce these sort of prompt injections. And yeah, I mean, this will be probably one of those new fields of study that will be much more developed in the next few years, exactly to avoid these problems.
Yeah, and it shows kind of, I mean, it basically signals the gap that still exists between the research side of AI in medicine and the actual deployment side of that. Nowadays, many people, including me and you, because we're hyped about AI, obviously think that, AI is going to replace, or even if not replace, at least enhance the current workflows that we have in medicine. The point is, even the most reliable models that we have nowadays, we yet know very little about their safe deployment. Uh, Hospitals, especially smaller hospitals that do not have this kind of huge background in AI research already, and teams who are active in AI, they know nothing about deploying AI pipelines, and they know nothing about the risks that come with just applying an AI model in practice. And this is a very easy example of how an advanced AI model could be tricked to give unreliable, unrealistic responses to the users, and this could have detrimental effects on everything. So I believe we have a still very long way to go, but we are also getting faster in traveling that way. So not sure how longer it will take us to get there.
Yeah, definitely. And how much else do you think?
I'm just going to introduce 3 papers and then I'm over.
Okay.
Those three
Okay.
papers are all related to each other. So it's basically one paper.
Yeah, definitely.
Okay.
And I think I am done.
Oh, you're done already? Okay.
Um,
So while you're
yeah,
looking at that, I'm going to
there
open.
are two other blog posts that I wanted to cover, but I think in for the sake of the time, I will probably ignore them.
So let me finish myself very quickly here. Maybe in 5 minutes, I'm going to
No,
wrap
no,
all three of those.
don't rush it. Just take your time and how you want to. Yeah.
The idea is kind of interesting, but I don't have much to say because I guess again it's kind of get very very specialized. The idea is very simple. These are some new publications from Meta again, and they have kind of focused on this kind of decoding language from the brain. This entire idea of decoding what is happening in the brain, and this is a very nice line of research in neuroscience, I believe, more neuroscience than medicine itself, but it could have a lot of medical implications. The idea is that is there a way for us to understand what is happening in someone's brain without needing them to open their mouths and telling us what they want to do? And obviously, you can think about all the implications it has in clinical side because we have lots of people who cannot speak. We have lots of people who basically even cannot type. They are paralyzed. They might have a lot of comorbidities that it makes them very hard for them to think. And you can just, and even for normal people, just imagine that, you and I now need to type, right? And instead of typing, but if you just think about what we want to write, right? Last night, I was just writing notes for some of my patients, and it took me, I guess, 2 hours to just put together 7 notes. And the bottleneck was basically just in the fact that I needed to say whatever I wanted to say. I wasn't even typing, I was just dictating that, and it still took me a lot of time. So huge area of applications available there. Now, what these people are doing is that they are relying on some sort of signals that we can get out of a brain functioning. The signals could be either understood by an fMRI device, which is basically an MRI focused on understanding the function of the brain, or an EEG scanner, basically the one that takes sort of basically that captures the waves coming out of the brain using special devices, or as we are going to see in this study, something between an MRI and EEG that I wasn't, to be honest with you, familiar with before. But this is something that they have done, and I'm going to find them. Yeah, this is called ME.
The magnetic encephalograph, I think.
Something between EEG and MRI. Am I right?
Yeah.
How I understand that. And I believe that's the way that they do it. And
Mhm.
this is cool. I mean, the way that they have done it is that, so I'm not going to play the sounds of this, but they basically say that they have had a relatively a small group of people, 30 people. They were all selected from expert typists. So those are people who could basically type, right? And they were put together, they were put within these devices, these MEG and EEG devices. They had both MEG and EEG arms. So they compared the performance of these two. And not obvious, I mean, not very surprisingly, the MEG group was more superior because this is a more advanced study. They were typing sentences at the same time they were thinking about what they want to type. And then the machine itself was actually decoding what the algorithm, the AI algorithm was actually decoding what the machine was capturing from their brain waves. And then what they tried to do was to compare what they actually wrote compared to what they mined actually sent out to those MEG devices. And it's a very nice study. So they put together two articles out of that. One of them is kind of a more introductory paper that they just basically try to, let me see which of those was. Yeah, this one, in which they try to basically think about how brains human work. And I believe there is a very nice figure in this paper that they kind of understand the human's mind. Let's see if this is the one or that was the other paper. I need to figure that out. Let's also open the other one here. Or maybe I'm open. Did I open two similar papers? Hopefully not. So I'm looking for a specific diagram in these papers that really caught my eyes, or maybe in the blog post itself we can find it. Oh yeah, here we go. So this is a very nice one. The brain generates a hierarchy of linguistic representations before typing each word, right? So what basically they discovered is that if you want to write a letter, if you want to write a word, your mind initially thinks about the entire concept that that word belongs to, and that is the first wave that is created here. You see, this is coming out of your brain, right? And this is mostly relevant to the entire phrase that you are going to write. This starts to pick up and it will remain on the top, right? Throughout the time that you are writing that. Then your mind goes a little bit more specific and think about the word that you need to write. It goes high. Then it goes towards the syllable that you need to write. It goes high. And then finally, one single letter, you write it, it's immediately comes down and another letter goes high. So they were thinking about this hierarchy of representations that your mind think of when you are going to write it. So it's basically, kind of linguistic way, but this is what I believe Jan LeCun always talks about, that we have a representation layer in our mind that is language agnostic, and this is basically this pink layer here. This is just the
Yeah.
concept layer, and then afterwards you need to translate that to whatever language that your mind is accustomed to, and those are the next ways, successive ways that come up. So they said that, okay, we now have this kind of understanding. That was the first conclusion out of that experiment. And then they said that now let's come up with an AI model that can capture and translate this. So their AI is actually very, very simple setup. They have a convolutional neural network, 1D convolutional neural network that takes these waves out of the brain, processes them first, comes up with some features. The features are actually fed into a transformer. The transformer creates some token predictions. And then finally, a pre-trained transformer like ChatGPT, GPT-4o, Cloud, whatever, that is not even accustomed to their use case, basically proofreads that sentence that came out of the brain. And now they are showing that if they do this pipeline, let's see if we have any results here. For the results, shall we go out there? So they show that basically their model, that the prediction coming out of their models is quite similar to the sentences that the authors actually wrote or typed on the screen. Maybe I have some pretty, yeah, here we go.
Yeah, and in the meantime, you're finding that. The thing that I'm still thinking about is the um, almost 1 second gap between where the pink wave was starting before we hit the keystroke on the keyboard. And I think that's a really slow process. It takes 1 second for our brain to come up from first searching for the phrase in the probably in somewhat embedding space like, and then to starting writing that letter.
Yeah.
And I'm thinking these LLMs with these latencies are really good at what they're doing. Probably they're doing much different things, but I mean, if our brain has latencies around 1 second from coming from two things that we think are should be really close together when the modules are working together, I think our brain is also very inefficient too. That was really weird to me.
I mean, I would like to say that probably our tools of communication, which is mostly the language, is very inefficient. And
Yeah,
now that you were saying that, just for a second, a very childish thought came to my mind that maybe, probably not very soon, but maybe in 500, 100 years, when this technology is actually far, far more advanced, do we still need language to communicate with each other?
yeah,
If we have a nice device here that can capture these semantics with the first wave and understands what we mean, and then instantly communicates that to another person who is standing in front of us or to a computer, do we still need to talk? I mean, we definitely do not need to type, and that's something that we can imagine for coming up in next 5 years. Probably in next 5 years, people are very rarely typing anymore. They are just thinking and saying something about everything being written. In 100 years, we might not even be communicating with each other through the language. It's just, semantics. So this entire idea of learning a new language might be gone. This is a
definitely.
crazy, childish kind of prediction of the future, but
I
that
don't
is
think.
what is happening
Yeah.
here.
Yeah, I don't think that's childish at all. I think that is the goal of the companies like Neuralink and those that are trying to implement chips in the brain so that we can communicate or connect with other humans
Mhm.
in other communication methods other than language, because language's bandwidth is really low for communication, and our unconscious and even conscious mind is probably much faster at finding concepts that it wants to convey, and it needs to put it in this communication way of language that takes a lot of time to find the word and to make the grammar right, and it takes a lot of time. It's very inefficient, and I think we will soon have methods to communicate on the concept level, and instead of just finding the right words to say. And as we mentioned in the previous episode on DeepSeek reasoning, in the case that it used different languages in the reasoning so that it can find the closest concept to the thing that it wanted to, but it didn't find it in English, so it used the similar thing from Chinese, for example. And we sometimes want to talk about concepts that are too abstract that we
Yeah,
don't know how to put them into words. But
yeah,
if you have a communication way or a communication tool that doesn't use tools and is only at the embedding or the phrase level of our brain, I mean, it would be much easier and much faster to communicate with other humans.
that
And you can imagine how art can be changed in this way,
nice.
or perceived, and how books could be made. It could be just an embedding of a book, and you can upload it. I mean, there could be lots of crazy ideas there.
Yeah, I mean, and this is very interesting. And I mean, everything could change. Just imagine that if you are a director and you are directing a movie, rather than
Yeah,
just creating a movie that everybody is going to watch and have the exact and see the exact same thing, you can just come up with the vague embedding space of your movie. And then if you watch that movie based on the memories that you have had in your life, you are going to see a completely different image compared to me, who I'm going to interpret those embedding spaces differently. So I guess we are going towards a very interesting direction in science and neuroscience. So, and these papers are just the baby steps towards that, right? I'm really excited to see these things coming up. And just quickly to finish this, and then I'm going to stop sharing. And if you have anything to add, feel free to do so. So they just showed the results. Obviously, there are only 30 people in this study, so this is not a study that you look at the statistics and quantitative numbers, but just look at here, this is the sentence that the person read. This is the sentence that the person tried to type. So basically, they read a sentence, they tried to type that. And now, based on the brain waves or brain signals, whether to say, here is the output of the models, like the first convolutional model that went through that captured something. The second the transformer afterwards made it much better. And then finally, a pre-trained frozen model on top of that, LLM on top of that, proofread that and gave you the final sentence out of it. So it's somehow nice that you can basically just read the sentence. Obviously, it is still very error prone. We have lots of mistakes there, and they talk about some details like, how much of these waves are coming from the motor part of the brain, so that if you weren't typing, maybe those parts could be completely flawed, and what part of that is coming just from your cognitive cortex. This is a very exciting line of research, right?
Yeah,
How
definitely.
can you do that? And then what kind of implications it has down the road for people who are paralyzed, who are blind, who are maybe basically just deaf, cannot talk, a lot of things. So I'm very, very
Mhm.
happy and excited about this.
Yeah, and also that human brain isn't fully focused on only the typing task at each time. So there are probably lots of other things happening at the mind that these models need to ignore for this task, but probably could also be learned with other huge models or more advanced models. And I'm thinking that it is a really crazy idea that you can read someone's mind from the outside without any intervention into the tissue of the brain. And I think one of the concepts of privacy for future years would
Oh,
be
yeah,
how
definitely.
not to be decoded by some technology and protect your brain waves not
Yeah.
to be attacked by some attacker. And it's just going to be a crazy world in a few years.
And you know that on the other end, basically on another world that we are a little bit far from, but still we are hearing the news of, the quantum computing is coming up, and all the encryption methods that we already know in the world are being treated very badly. So even if you say that I'm going to encrypt whatever is coming out of my mind so that nobody can reach out to, chances are very high that neither of those encryption algorithms are useful until we come up with something that could be resistant towards those computations, and quantum computations. And this is crazy.
Yeah, definitely.
Very
Just
exciting.
imagining and about the future really excites me that
Very exciting.
lots of new technologies will be available soon.
Yeah, yeah. Anyway, so that was the end of my list of resources to share. I also wanted to talk a little bit about a couple of RAG techniques, but neither of those are new, so I can leave it for the next time we talk with each other. So I'm going to stop sharing. If you have anything left, feel free to go ahead and share.
Yeah, I will just introduce the whole concept or basically the link to them so that people, if they are interested, they can dive deeper into. And one of them is about the new wave of AI engineering as a role, as a kind of career. And let me find the links here.
You have not
Uh,
shared your screen, by the way.
yeah, I know. I'm just trying to first find it and then share. I will share my screen. Okay. I have too many open tabs. Okay. And I mean, too many open windows actually. And yeah, the rise of the AI engineer. And I found this one from the AI engineer book by Chip Hoyen that I'm currently reading very slowly, but by the way. And this is the gist of it is that the landscape of machine learning research and the jobs around it is changing rapidly. And a new kind of role, which is not very new these days, is the role of AI engineer, which this blog post actually claims that it is very different from the ML researcher that we are used to, the prerequisites and the tasks they do. In this way, it is in a way that this blog post introduces it is very much closer to software engineering, and this is something that I really that makes sense to me as well, is that having software engineering skills is much more important at this stage of AI development because if you are a good software engineer and you're good to experiment with and work with APIs, you can just grab an API from OpenAI or somewhere else and then go build the product you have in your mind. So two skills that this post actually focuses on are the software engineering skills and your understanding of the product management, basically. And it says that if you are good at these two, you will be you can make lots of money in the new years, in the future years to come. And it's uh, kind of compares some of the um, basically how people think about the requisites of ML research, ML engineering with AI engineering, and it says that people still think that to become an AI engineer, you need to be good at math and be good at PyTorch programming, but it has another view on it, and it says that you don't need to have a good math background, you just need to be good at coding and building things that people want to pay for. And as long as you're good at those two skills, you can make lots of money in these days. And yeah, there are other kind of paragraphs on how the AI engineering emerged from prompt engineering. And this was also cool. And it goes on to the reasons why AI engineers are emerging now. And it goes like there are lots of foundation models. The big companies are hiring all the research scientists so that you don't need to hire them yourself. You can just rent their intelligence via their API, which was a nice framework to think about. And yeah, and in this figure, I think, and this paragraph was a bit thought-provoking, the fire, ready, aim approach instead of ready, aim, fire. And it says that, let's see here, instead of requiring data scientists and ML engineers do a laborious data collection exercise before training a single domain-specific model that is then put into production, here, a product manager, software engineer, so the two skills that I just introduced, can prompt an LLM and validate a product idea before getting a specific data to fine tune. So because these LLMs are good at many things, they're not very they're not expert at any topic, but they have a broad knowledge, and they can, I mean, do 10% of the product that you have in mind, basically with their current knowledge. You can build the product with that bad kind of backbone first and see even if anyone is interested in this MVP, and then you can find your find your customer, and then that customer interacts with your model, so you have data, and then you can fine tune on the kind of data that your user actually interacts with. So they argue that this changes the whole pipeline from data to model to product, to first build some product that actually works, then grab the data and then fine tune your model. Which I think this will be probably some of the changes that the field will see in the years to come.
Definitely, very nice one. And very nice line of work for people who want to get into AI, but who are not familiar with AI research anymore, because I know part of the frustration for new people who want to jump on
Yeah.
AI uh, line of research is that, there is a lot already happening. There is a lot that has already happened. So by the time that we try to catch up with what is state of the art today, we are still far behind from the state of the art on that day. So I would say that this is kind of reassuring to those people that, yeah, no, not everyone needs to start from attention is all you need. You basically just need to know how to work with the API. And if you are a web developer, you could basically just try to be an AI engineer in some sort if you also learn a little bit about safe AI deployment and things like that. So I guess, yeah, that's kind of an exciting future for people who are interested in AI, but have not yet started the research path here.
Yeah. And yeah, I mean, this is on the assumption that you want to build products to make money.
Mhm.
If you want to contribute to the research, you still need to go through those papers and techniques. You need to be good at math and coding and everything. But for someone who wants to play with these models and just solve problems, the cool thing about this day of AI is that with these lots of code assistants and lots of APIs and documentation available, you can just start building the thing that you want, and then think about, okay, how I want to fine tune it in an efficient way. Okay, I need to learn about quantization. I need to learn about how to train a model on a GPU. And I'm sure that if someone is good at coding and uses some of these assistants, LLM powered assistants in coding, that wouldn't be a very difficult thing to do.
Agree. I agree.
Yeah, I will stop here. And I think if you don't have anything else to share, we can probably finish this episode here.
Yeah, no, I don't have anything more to share. Again, I learned a lot from you, like previous meetings that we had together. So thanks for sharing everything. And I
Likewise here.
watched us also learn one thing or two from this. Like every other sessions, we are going to share all these resources in our caption as well. So feel free to take a look at these links if you were interested in any of those. All right,
Yeah,
so
so
yep,
very
let's
nice.
say farewell until the next time then.
See you.
Yep, see you. Goodbye.